Imagine the end of everything. Not with a bang, but with a silent, sudden shift. One moment, the stars are shining in the night sky. The next, they are gone. Not just the stars, but space itself. Time, matter, and all the laws of physics as we know them would simply cease to be. This isn't a scene from a science fiction film. It is a possibility rooted in our deepest understanding of the cosmos. It's a concept that keeps some physicists awake at night. This idea suggests our universe might not be as permanent as it seems. It could be resting in a fragile state, one that could break at any moment. This catastrophic event has a name: vacuum decay. Imagine a ball resting in a small dip at the top of a very large hill. As long as nothing disturbs it, the ball will stay put. This is our universe, existing in what physicists call a false vacuum. But just over the edge of that dip lies a much deeper valley below. To better understand this, let's return to our analogy of a ball on a hill. But now, imagine not just one hill and one valley, but a vast rolling landscape of hills and valleys of varying depths. This is what physicists call a potential energy landscape. Each point represents a possible vacuum state for the universe, and the height represents the energy of that vacuum. The Higgs field is, honestly, one of the most important discoveries in modern science. You can think of it as a kind of cosmic molasses that fills the entire universe. As different particles move through this field, they experience a sort of drag, and this resistance is what we actually perceive as their mass. The discovery of the Higgs boson particle at the Large Hadron Collider in 2012 was a monumental achievement. The crucial detail was the Higgs boson's mass. The teams measured its mass to be approximately 125 giga-electron volts. This number was a bombshell. It fell squarely within the narrow window that would place our universe in a metastable state. Let's imagine that somewhere in a distant, forgotten corner of the cosmos, this quantum leap finally happens. A tiny patch of our false vacuum tunnels through the barrier and collapses into the true vacuum state. This transition would release a colossal amount of energy, creating a bubble of true vacuum. This bubble would immediately begin to expand outwards in all directions at the speed of light. Its wall would be a shell of pure energy, a shockwave of cosmic change. Nothing can travel faster than light, so there would be no way to see the bubble coming. One moment, a distant star system would be there, following familiar laws of physics. The next, it would be engulfed and instantly converted. So we are faced with a potential cosmic catastrophe. The most pressing question is, can we see it coming? Is there any way to build an early warning system? The answer, according to physics as we understand it, is a definitive and unsettling no. The wall expands at light speed. Since nothing can travel faster than light, there's no signal that could outrun the bubble and warn us. We would be destroyed at the precise moment we could have known something was wrong. It is the universe's ultimate blind spot. This makes vacuum decay completely different from other cosmic dangers like asteroids or supernovas that send advance warnings. We have journeyed to the very edge of physics and imagination. We have stared into the abyss of vacuum decay. This concept suggests our entire universe might be a temporary arrangement, a fragile bubble of reality waiting to pop.